Welcome, listeners, to HP News Channel, where we explore the technological breakthroughs shaping the future. Today, we'll delve into a quantum leap in the field of artificial intelligence, an achievement just announced by tech giant Google, promising to usher in an entirely new inference era. That breakthrough is the 7th-generation Tensor Processing Unit, named Ironwood. At the recent Google Cloud Next 25 event, Google officially unveiled its most powerful AI chip to date, Ironwood. This isn't just a typical upgrade. It's a revolution in performance, specifically designed to reinvigorate artificial intelligence models, especially in complex tasks demanding reasoning and intelligent prediction. Unlike previous generations of TPUs, which focused on training AI models from the ground up, Ironwood is born to serve the inference phase, the process where AI uses the knowledge it has learned to solve real-world problems, make decisions, and interact with the world. Imagine the brain of an expert, not just collecting information but also analyzing, inferring, and acting upon that information. Ironwood is precisely that kind of superbrain for AI, and Ironwood's power is truly astonishing. According to Google's announcement, when deployed at scale, with 9,216 chips in a pod, Ironwood can achieve a computing power of 42.5 exaflops. To put that in perspective, 1 exaflop is equivalent to 1 quintillion floating point operations per second. This 42.5 exaflop figure isn't just a Google record. It's also 24 times faster than the world's current fastest supercomputer, El Capitan, which peaks at 1.7 exaflops. A difference that's truly night and day. So, what fuels Ironwood's extraordinary power? The secret lies in its architecture and impressive specifications. One of the key elements is high bandwidth memory, or HBM. Ironwood boasts an HBM capacity of 192 gigabytes, 6 times that of its predecessor, Trillium, which Google announced last year. This large memory capacity allows Ironwood to handle massive and complex AI models smoothly, avoiding data bottlenecks. Furthermore, Ironwood's memory bandwidth reaches a staggering 7.2 terabits per second per chip, a 4.5-fold increase compared to Trillium. High memory bandwidth means data can be transferred to and from the processor rapidly, optimizing computational efficiency and minimizing latency. Amin Vadat, Google's vice president and general manager of ML, systems, and cloud AI, emphasized Ironwood's importance in supporting the next phase of generative AI, as well as its enormous computational and communication demands. He calls this the inference era, where AI agents actively access and generate data to collaboratively deliver insights and answers, rather than just processing data. Google isn't just introducing powerful hardware, it's also revealing how Ironwood will power its most advanced AI models, notably Gemini 2.5. At the Google Cloud Next 25 event, a special version of Gemini 2.5 was unveiled, named Gemini 2.5 Flash. Gemini 2.5 Flash is designed as a more economical version of the flagship Gemini model, with the ability to adjust its reasoning depth based on the complexity of the input prompt. This means that for simple tasks, Flash will operate quickly and efficiently, while still being able to unleash the necessary reasoning power for more challenging questions. While Gemini 2.5 Pro is aimed at high-end tasks like drug discovery and complex financial modeling, Gemini 2.5 Flash is optimized for rapid, everyday use, where speed and responsiveness are paramount. The combination of Ironwood's hardware power and the flexibility of the new generation of Gemini models promises to deliver smoother and more intelligent AI experiences than ever before. Ironwood isn't simply a standalone chip. It's a crucial link in Google's broader AI infrastructure strategy. The company is building a comprehensive ecosystem, from powerful hardware to intelligent software and advanced cloud services, to meet the ever-increasing demand for AI computing power. Another important part of this strategy is Google's introduction of Cloud WAN, a cloud-based wide-area network management system. Cloud WAN allows businesses to directly access the infrastructure of Google's global network securely and efficiently. This not only helps accelerate data transfer for AI applications, but also ensures the stability and flexible scalability for large-scale AI projects. With the launch of Ironwood and Cloud WAN, Google is demonstrating its ambition to lead the AI race, not only in its ability to develop intelligent models, but also in building a solid infrastructure foundation to support them in the future. So, what changes will the arrival of Ironwood and the inference era that Google mentions bring to the future of artificial intelligence. With unprecedented computing power, AI models now have the potential to handle more complex tasks, make more accurate predictions, and interact with the world more naturally and intelligently. We can expect breakthroughs in AI applications across many fields, from healthcare, more accurate disease diagnosis, faster development of new drugs, to finance, more sophisticated risk analysis, more efficient algorithmic trading, transportation, safer and smarter autonomous vehicles, and even content creation, generating more unique and engaging works of art. However, alongside these immense potentials, the inference era also raises questions about ethics and responsibility in the development and deployment of AI. As AI becomes increasingly intelligent and proactive, we need clear regulations and guidelines to ensure that this technology is used for the benefit of humanity. With the introduction of the Ironwood AI processor, Google has once again demonstrated its pioneering position in the field of artificial intelligence. Ironwood's superior computing power, combined with the advancements in Gemini models, promises to usher in a new era for AI, where the inference and interaction capabilities of machines will reach new heights. However, the journey of AI development is still long and full of challenges. Maximizing the potential of technologies like Ironwood requires close collaboration between researchers, developers, and policymakers to ensure that AI serves the common good of all society. Thank you for joining HP News Channel for today's episode. Stay tuned for the latest information on the technological breakthroughs that are changing our world. Goodbye, and see you in the next episode.